Good morning, good afternoon, good part of the day, everyone. Welcome to the largest, fastest growing, and the most active large-scale Scrum community meetup. Started in New York City and has gone viral. Today, I have the pleasure of hosting and having in-house a good friend and colleague of mine, Asaf Ronen. Um, and just a couple of words about Asaf so that we serve justice to the speaker. He's the speaker today. He's the Carnegie Mellon University graduated with 26 plus years of experience as a digital transformation coach, organizational change agent, software architect, and software developer. Asaf coaches modern engineering, product mindset, agility, and agile culture. Asaf has worked at big and small company such as Wells Fargo, Bank of America, ATS, AT&T Labs, as well as some other smaller startups. He's got his own Coach Me to Mastery channel on YouTube. And if you want to learn any transformation content from him directly, please sign up for his channel. And we will be sharing his information later with a wide audience. In his free time, he's a avid trainer, a trainee, and a coachee, and I guess he does both, trains and coaches in various types of martial arts, and just does a lot of fun things. I'm going to pass the baton over to Asaf. Without any further ado, if you have any questions, please kindly raise your virtual hand or physical hand if you have your camera on. In fact, I do ask you all to turn them on if you could, and keep your mics off. And we shall record a session just in case if you ever want to replay it. Asaf, I'm going to pass it on to you. Please
Well,
take it.
thank you very much, Gene. Welcome, everybody. This session is titled, Can You Really Be Agile If You're Afraid of Your Code? And what I hope to convince you today is that if your team adopts a test-driven development way of working, they can gain really high confidence to modify any code. So that's what I hope to convince you. And this session would be better if I kind of understand who you guys are and what roles you play and interests. So we'll get to that in a second. But before I do, just quick working agreement. For those of you in the Agile space, you may know what I'm talking about. Let's do a little working agreement for this session. If you can avoid distractions, focus on this, that would be awesome. Please participate, okay? So be engaged, ask questions, share your experiences. This is not just me talking. The more we all kind of make it interactive, I think we'll get more value out of it. I hope we can be vulnerable and we can all respect each other with that. I don't know everything, right? Even in my line of work where you're supposed to know everything, I don't know everything. So I hope to learn something from you guys too today. And if you can, I think we're pretty good with, I see people are on mute. So great, be on mute, but please feel free to get off mute and speak up. You can interrupt me. If it gets out of control, then we'll switch to raising hands. Okay, so there's a lot that we can do today, right? The space of what I want to talk about is big, but we only have an hour. We even have less than an hour. I would say we probably have half an hour. So to help me do a better job, let me get to know you guys a little bit better. Okay, and for this, you'll need to know how to raise your hand in Zoom. And I have the instructions here if you need them, although I see it's a little different on my screen. But can you raise your hand if you're a developer? You write code. So if you write code, okay. Brian, Monty, and it's okay, it's just kind of trying to see where we're at. So we have two developers. Okay, that's fine. And how about folks, how much, raise your hand, so you can lower your hands. Okay. How many people who has some kind of knows something about unit testing, has done it before, heard about it? Okay. Hey Jeff, good to see you. Doug, okay, so we have some experience. 1, 2, 3, 4. Okay, good. So quite a few people. 1, 2, 3, 4, 9. Okay, okay. So I will start from basics, but you guys help me either speed up or slow down as needed. We can get as deep as you guys may want. Okay, how about this? Lower your hands. How many people deal with legacy code, like old code that's been around forever and you need to maintain it? How many people we have in that space? Okay. Quite a few. Good. Okay, okay. So this should be relevant to you. Last question. What I could do in this session, I don't have a lot of developers, but what I could do is actually open up some code and show you. I use Java. That's what I primarily know. How many people kind of seen Java, kind of can understand Java? I won't get, okay, oh, good. So quite a few people. So, okay, okay. So we may go in there and I may show you some stuff. Awesome. Thank you so much. Okay, so let's get started. Let me put this in full screen. Okay. So for developers, right, writing new code can be really exciting. Okay. If I'm given a new application to write, a new microservice or some new component, I get to write it from scratch, right? I get a blank slate. I can design and build it however I want, right? So that can be very exciting. But what do you think about modifying legacy code? Okay. And before we talk about how you may like feel modifying legacy code, can someone tell us what's legacy code? How do you define it? There's many ways to define it. Well, what's your definition of legacy code? Anybody? No wrong answers.
Okay, I would say it's code that's been around for more than 5 years is what I
Okay.
would call
Okay. Thank you, Ofer. Anyone else?
Any code that's been released.
Yeah, yeah, right, right. I've heard that definition too, right? As soon as it's out, it's already legacy.
Yeah.
Anyone else? So that's pretty much it, right? It's code that's already released, it's been around for a while, maybe it hasn't been touched. There's different ways to define it. Whatever definition you use, it's fine. What I would like to know is, especially some of the developers on the call, how do you feel if like you had to go in and modify this legacy code? And there may be different sentiments. I'm just curious to hear your thoughts. Scared. Okay. I'm sorry, I should monitor the chat. Scared, right? So that's definitely right. It could modifying legacy code could definitely be a bit intimidating, right? Sometimes we're a bit hesitant, maybe a little fearful. Why would we be intimidated? Why do you think we may be intimidated to modify legacy code? That old code that nobody has touched or seen in a long time.
Because you're uncertain what it's supposed to do.
Yeah, maybe you're uncertain what it's supposed to do. And if you're not certain, then what could happen?
May or may not have unit tests around it, automated tests around it.
Yeah, and we'll get to that. But yeah, so you could break it, right? You could break the code. So, someone else's code, maybe you're not familiar with it. You're afraid maybe you break it by mistake. Maybe it's even my own code. I haven't touched it in a long time. I forgot how it works. Maybe the original author is long gone and the code hasn't been touched in years. Maybe it's old technology, which we're not as familiar with. maybe it's high risk, right? Millions of customers use this code. Our reputation is at risk, potential financial losses, right? That's a heavy burden on your shoulder, like to have, right? Maybe the code is hard to understand, it's very complex, maybe it was poorly implemented, maybe got really messy and convoluted over time. That's a technical debt, maybe has no documentation. So there's good reasons why developers may be a little hesitant to touch legacy code. So here's an example. Okay, let's say you're asked to modify this function, this code, which calculates the fair value of convertible preferred shares. And from what I've seen online, it's a pretty complicated formula to implement. And oh, look, there's some comments here. Let's see. In 2020, the original author left the company. Okay, so he's not around anymore. 2021, the team wanted to make some changes, but nobody really understood the code, so they kind of didn't want to touch it. In 2022, we actually made a change and rolled it to production, but it broke something. We had to roll it back, caused a 3-day outage, resulted in millions of dollars in losses. Thousands of customers closed their accounts. The break made global headlines affecting our reputation. So in 2024, please don't break it, but I need you to go in and make some changes. So you see the sentiment here. I'll give you one more. This is the traditional way of working with legacy code kind of gives you this really nice incentive formula. Okay, of course, I'm being a little sarcastic here, but can you relate to this, right? You may ask yourself, does the code work? Yes, great, leave it alone, you're good. Does it not work? Well, did you change it? Well, you fool. Does anyone else know? No? Okay, hide it. Someone knows? Can you blame someone else? So, this is a bit to be funny, okay? But really the traditional way of working, this is what you're handed, right? And sometimes there's consequences and it could be kind of scary. So let me ask you this. What do you think this does to our agility? Right? If we're afraid to touch our legacy code, what does this do to our agility?
Oh, that's why I
Well,
love doing startups. Yeah, we can move faster. We're not breaking. We love breaking things. It means we're learning. But yeah, big companies have legacy stuff to worry about and customers.
Yeah, that is very true. So when you're a young startup, you take more risks, right? Once you build a big company like some big corporation, you have a lot to lose, right? You have a lot to lose. So it's a bit more intimidating to make changes to something that millions of people use that could break. So again, how does being afraid to modify your code or being intimidated, right? You're not like, how does that affect agility? Like tell me more, guys. What do you think?
Well, it definitely makes you, it goes against the whole essence of agility because you're afraid to make any moves because of the repercussions that could come. So you're in essence tied down almost because you can't really move. You're not flexible because you don't want to make any mistakes. So you're not agile.
Yeah.
If
Anyone
you're
else?
afraid, if you're afraid to touch the legacy code, eventually almost all of your code will be legacy code.
That's right, Hal. Yeah. Anyone else wants to chime in? So that's right. So our team, if we're afraid of our code, our team is likely to avoid modifying that old scare code. So we'll do anything not to change it, right? We'll even wrap it in more code just so we don't have to touch it. And we basically, over time, bury ourselves in more and more technical debt, right? And the more technical debt we acquire, the more difficult it becomes for us to make changes, and the slower we become, right? So there is a link there, right? You could be practicing Agile, but if you know, you lack some of the modern engineering practices that give you that confidence, then it actually slows you down. It doesn't matter how much you're practicing. Okay, so what I want to do now is I want to inspire you guys and show you what's possible, okay? So, whoops, let me go back, get out of this. So what I'm going to do is I'm going to bring in, bring this in. And what this is a development environment. This is IntelliJ. This is the tool that developers use to write code, okay? And what I'm going to do is I'm going to show you what things could look like for a developer. And even if you're not a developer, the appreciation of what their day-to-day work could look like, I hope that will inspire you. Okay, so what you're looking at here is, whoops, that's not what I meant to do. Here we go. We have a class called password that basically holds a password. And we have a method on it where we can say, hey, is this password strong? Okay. So we have some definition of what it means for a password to be strong. Let's say it has to be at least 6 characters long. It needs an uppercase, a lowercase, a digit, no spaces, some special characters. That's our definition of strong. Okay. And this code is already written. Okay. In our development environment, right? This is where developers do their work. They write code. These tools have very strong support for what we call unit testing. And what you could do right here in your development environment is you can run what we call unit tests. So I have here 1, 2, 3, 4, 5, 6, 7 unit tests, right? 1, 2, 3, 4, 5, 6, 7, 8 unit tests. And as you can see, they have green check boxes. That means they pass. These unit tests, what they do is they very specifically make sure that this function is strong, that tells us if a password is strong. It tells us whether it passes all these different test conditions, right? If we give it a password that has no special characters, then it should say, no, it's not strong. Well, that test passed. If we say, here's a password that has no lowercase, it should tell us it's not strong. Here's a password that is strong, you know, and okay, it tells us that it's strong. So what if, okay, I'm here, I'm developing code. By mistake, let's say I delete or change this code. I'm just going to represent it by commenting it out. I'm going to rerun my unit test. And look, a test failed, and that's okay. That's okay. Why is that okay? It's okay because as I'm developing, right away, I know I broke something. I don't have to wait a few weeks or 2 months until some other tester is going to tell me that something's broken. I'm literally here developing, and I can run this many times a day. And you can see here, it's milliseconds. We're talking milliseconds. So I can do this many times a day, right? As I'm code, I'm more confident because if I delete something, I can fix it. I can rerun my tests. Everything passed. Okay? Let me give you another scenario. We have this code, right? It's strong. Millions of people rely on this code to work, right? When they change their password, this is the code that checks if their password is in fact strong enough. Let's say this implementation is inefficient. It takes too long to run, or maybe we're running on a device that has limited memory. We need to have less lines of code, use less memory. As a developer, if I have these unit tests, I could feel confident, and let me show you, I'm going to completely re-implement this. This is something that normally would be really scary for someone. I'm going to delete all the code, and I'm going to completely re-implement it another way. So give me a second here to grab some alternate code. Where did it go? Here we go. Oh, where is it down here? Oh, here it is. Okay. I'm gonna re-implement this whole thing using something called regular expressions in 2 lines of code, right? Completely different implementation. Normally, this would be completely scary. I could totally break things, right? So, okay, fine, no problem. I'll rerun my unit tests. Most of them passed. 1 failed. That's okay. That's okay, because guess what? I found out right away, right? Right away. I didn't have to wait again a few weeks, a few months for someone to tell me I broke something. I know it right now. And guess what? I found out I broke something before I put my new code into version control and merged it with other developers' code, and it became a bigger mess, right? I didn't affect anyone yet. I found a problem before anyone else sees it, immediately as I broke it, right? So, okay, so now I can go in and let's fix the bug. I'll grab this other code if I can copy and paste. Copy, and then let's move up back up here. Put this new code. Let's rerun. There, I fixed my problem, okay? So this is, in a nutshell, what things could be like if we used unit testing. Give me a second here. I lost your pictures. Okay, here you go. So what do you guys think?
Yeah, I used to be hands-on, and these days I'm not as much, but I'm more of a product manager. And last week we had this change we're implementing where if you move from annual to monthly billing, you know, we want to test all the corner cases, but it's over time. So have you experienced like unit tests that require like testing what happens over time if the right things happen?
So great question, great question. So there's different types of testing, okay? And this type of testing is more focused on functionality. I guess it could be used for performance, but it's not really designed to be the best. Anybody else has some comments on this? We can learn from everybody else too.
So one of the problems with this type of issue is that in a lot of cases, what you'll see is you can have code in there that was put in there because of some wildly rare scenario, and it was code that was added because somebody finally figured out it was probably a bug that they were looking for a while, because it's not something that happens often. And that's one of the reasons why if you go up to your requirements people and you say, what is this code? They'll tell you, I have no idea. It's been in there forever. Don't touch it because I don't want it broken. But it obviously it was put in there for some reason. And in my opinion, that's the reason why these problems are in there. These are not obvious problems. These are probably wildly rare. And you're not going to catch that with unit testing because somebody probably put that fix in there as part of some other like bigger scenario. And unit testing, you're testing a like a unit versus scenario testing. So that's why I believe in a lot of cases, this isn't gonna work very well.
Yeah. So good question. So let's keep it moving. We're halfway in. What I want to do now is I want to give you guys a bit of visual, just to explain to you a little more what unit testing is, okay, visually. And then we can jump and talk about, one thing I want to talk about is what skills do you need to get really good at unit testing? And then really talk about the value. What do you get out of it? Like what's in it for you, right? So first, let me kind of get into, just give you a better understanding of what unit testing is, okay? So imagine this circle is your application code, okay? And if we're in an object-oriented programming language, which is majority of stuff, it doesn't have to be for unit testing to work, but let's assume it is. And you have all these objects in your code. And these objects may do different things in your code, right? Let's say we have a banking system. This object may be responsible for money transfers, right? I want to move $100 from my checking account to your checking account through Zelle or something like that. And let's say this other object here is responsible for fraud. So we can tell you if your bank account, for example, is in a sanctioned country, okay? Now, these objects don't work in isolation, right? They use each other, they call each other. Like the object that's responsible for transferring money may ask this fraud class, hey, are my bank accounts in a sanctioned country, right? And there's also dependencies on external things like databases and other services and files. So everything's very connected, right? My transfer class may change the balance in the database of in an account, right? So now, because we're human, it's very natural and expected that we're gonna have bugs. We're gonna have bugs everywhere, okay? Some of those bugs are in these classes, okay? Where we have the actual logic of, let's say, transferring money. Other bugs may be on the integration of how these things work together, right? How when I make a change in the database, maybe the way I do that, there's a bug in there. So what we do when we do unit testing is we isolate all these objects. These are the units we're testing, right? Unit testing. We're testing units. What are the units? In an object-oriented language, it's these classes, okay? It's really the methods inside the classes, but let's say it's these classes. And what we're doing, again, big picture, when we're unit testing is we're focused on first eliminating all the defects within these objects. Like just make sure the code in these objects work as expected, okay? And then once we look at the whole thing together, right? And now we're trying to test the whole thing integrated with all the complexity. Now that we removed, I call it the noise, the defects from the units themselves, it's much easier to debug and find issues because probably most of the issues remaining are between how things are integrated, okay? So that's kind of one of the benefit and the idea. So back to these units. Let's pick one. So let's say this is a class that we want to test. And I'm assuming I'm using vocabulary of object-oriented programming. If you guys get lost, let me know and I'll help you out. But in unit testing, this is what we're testing. Okay, we're testing this class. Okay, and the way we do that is we create a corresponding tester class. This is code that lives outside of our application, whose sole responsibility is to make sure the code in this class behaves as we expect, right? For example, transfer money between bank accounts, right? One scenario this tester class may test is happy path. Let's try to move $100 between my account and your account, assuming I have enough money, assuming we're both not in sanctioned country, okay? That's one test scenario. You may test another scenario. Maybe I'm trying to move $500, but I only have 100 in my account. So how should what's the behavior, right behavior for handling that kind of error? Maybe I ran out of my limit of transactions for the month. Let's test that scenario. So all the different scenarios to make sure this code works. Now, if you guys remember, we said these things in reality, in production, they don't run in isolation. When this tester class asks this transfer class to do something, it may call other classes to do things for it. But guess what? If something breaks in another class, we're not interested in that because that affects our focus is just this code. So what we do is we use something called test double. So this is something when you're kind of trying to mature in doing unit testing, you need to learn how to write unit tests. You need to learn how to come up with interesting things to test. But another thing you need to learn is how to isolate your code so it doesn't depend on that external database that you may not have in your development environment, right? You do unit testing on your PC where you're developing code. You may not have that production database. You may not have those services you need to call that you depend on. So what you do is you use something called test doubles. We don't have time to get too much into it. But a test double helps the tester class so what the tester class can do is it can tell the test double, hey, when you try to do a transfer of $100 from my account to your account, and this transfer class asks you, hey, are these accounts sanctioned or not? Just say no. Don't actually go and figure out if they're in sanctioned, right? Just canned response, dummy response, just say no, because I don't care about this other code. I'm not testing that code right now. I'm only concerned with this code. So anyway, any questions on this? Again, we're not getting very deep into test doubles. Examples you may have heard of mocks, stubs, spies, dummies, fakes. Those are all different kinds. We don't have time to get into that, but is the general idea of what I'm saying clear? Anybody have any questions?
The way I like to tell people is if your unit tests access the database, it's not a unit test.
Yeah. We try to abstract and kind of dummy up all these dependencies. Because remember, I showed you, let me bring it back. They run in milliseconds, right? I mean, I rerun these run in milliseconds. They need to be able to run on my computer as I develop. I don't care about those dependencies, right? I want to be able to run it now quick with minimal setup. Thank you for that. Okay, so let me move on. Let's do this. Let's do a quiz. Let's play a game. Just to kind of recap. Questions, answers. To recap and kind of learn as we go. What is this unit we're testing? So now we said, what are the units? Like in an object-oriented language. Anna, say it out loud, Anna. Don't be shy.
Class.
Yes.
Class.
Right, the classes, or even the methods within the class. So as we practice, because some languages are not object-oriented, they're procedural. So those functions, right? But those classes. Okay, so how granular is this type of testing? Is it very granular? It's a high level. What did you see? How high level or low level? Is it high? Is it low? What is it?
Super granular.
Yeah, right. It's very, very low level type of testing, very granular. Now, what are unit tests made of? And you may not know what I'm trying to say here, but what are they made of? Are they some script that a tester kind of follows to manually test something? Or is it something else? Feel free to guess. There's no wrong answers. Be brave.
Is it a tester class and stubs?
Yeah, so basically it's code, right? That's all I was getting at. So unit tests are code. It's code we write to test code, right? So thank you. Yes. Thank you for being brave. Who writes these unit tests?
The developer.
Yes, you get a brownie. The developer, right? It's the developer. It's not someone else. Which developer? Is it like I develop code and then I give you my code and you write unit tests? Or some other way? Which
Ideally,
developer?
it's the one making the code change.
Yeah, that's right. It's the one, like as I'm developing, I'm writing unit tests, and we'll get into TDD and test-driven development in a second. But it's something I'm doing as I'm developing. So me, the developer writing the application code, writes also those unit tests. Very good, very good. So
So I
when?
want to
Yeah,
circle
please.
back to what the other gentleman said. I
Mhm,
forget who it was. That,
mhm.
oh, there's code that was written. No one knows what it does. No one is. Everyone's scared to touch it. So that was if they had good practices. That developer had written the test cases. That would have helped with that. But if it didn't happen, do you then go back and write test cases? I guess new developers do it if the person left.
Very good question. And I actually kind of skipped that conversation, but let me go back to it because I was planning to. So let me just click to it. So imagine we're here, right? Oops, okay, it already did. So what is the strategy to get started, right? So excellent question. Thank you for asking. So imagine you already have an application. You have hundreds of objects, maybe even thousands, right? You have a lot of code and it's already there and you're starting. What's a good approach to getting started? I can say, but I'm just curious. Someone else wants to chime in. Like it could be so overwhelming, right? So how can you get started? So there's a very simple approach. A very good way to get started. That's a good strategy, is if you touch the code, you write unit tests for the code. Okay, so let's say, for example, this object I have to modify. That's the opportunity to create a tester class for it to test at least the modifications I just added. If these two are brand new classes, we 100% accompany it with a tester class to test that class. So now, why in this strategy don't we write unit tests for this class over here? So let's say it's in production. It's working. We haven't touched it. We don't need to change it. It's working. So we don't necessarily need to. Of course, you can. You have the time, you have the bandwidth. Go ahead and add unit tests. But a very good way to start is to say, if you touch the code, whether you update something or you're adding something new, that is the opportunity to add unit tests for that code, because that's new code. New code is more risky, right? Existing code in production most likely works. If once we do this, and as a practice, the code that gets into production is more likely, right? There's always things that slip through. So very good question. I'm glad you asked it. Let me just get back to here. And let's get through the rest of them. Okay. Let's see. So you guys already got all these. Unfortunately, I can't jump ahead. Okay. So who writes the code? The developers. And then we asked, when? When do we create the unit test? As we code, right? As we code. Where do we run our unit tests? Reflect on what I showed you. What environment do you run your unit tests? And there's not just one answer, but where do we run our unit tests?
Well, locally on your machine.
Yeah, that's the first place. Thank you. Locally on your machine, your development environment. Of course, if you're familiar with CI/CD, continuous integration pipeline, of course, so basically the idea, the other place that it runs automatically is you have your code, and let's say you're happy with it. You run all your unit tests, everything runs, you're pretty confident, you check it into version control. As soon as you check it into version control for safekeeping, and so other developers can see your code and integrate it into their code, at that moment that when you check your code into version control, automatically the CI pipeline kicks off, and guess what it does? It tries to build your code. If it compiles, it then runs all your unit tests automatically, because if anything breaks, it immediately lets you know, hey, you broke something, you checked in something that's broken, other developers may pull your code to integrate it. You may want to fix it right away. Advanced question. Anybody who's doing unit testing, and is there even a more advanced way to kind of prevent untested code to get into version control? So you can actually configure your CI pipeline that when you do a check-in, normally it does a check-in first, it puts your code in, and then it runs the unit test on it. There's ways to say, well, run the unit test first, only put it in if they all pass. So again, something you could do. 2 more questions. Remember we said we test these units in isolation? Let's recap. Why do we test these units in isolation? Who remembers?
So that we're just doing the unit that we're testing and not the integration between areas.
Right. So one reason is definitely it's not within the scope of what we care. We just care about the unit that we're currently focused on. So that's one reason. That's a very good reason. Any other reasons?
It's easier to isolate the bug in the unit. I mean, because once it sort of gets wild into the system, to track it down is much more difficult.
Yeah, absolutely, right? It makes us a lot more efficient. And the other thing I was looking for, all good reasons, there's many good reasons, these dependencies may not be available to us in our development environment, right? That database may not be there. And guess what? We don't need it for unit testing because we're not testing the database. We're just testing. You could unit test your database scripts and stuff like that. But at the moment, you're just focused on testing some code that depends on the database, right? So that's that. Okay, last question. What do unit tests create for us? What's that value we get? What do we get? There's many answers to what value, but what does it create for us?
Security.
Security. Yeah, it gives us this safety net, right? That's the confidence we have to modify legacy codes. We have this safety net, right? And guess what? It also acts as very good documentation, right? If I go back to, let's pull this one. Okay, and let me hide this. Let me move this a little bit. So here's our unit tests, right? Is the password strong? No, because it's shorter than 6. Is it strong? No, because no up. It's documentation. If our team has a new developer coming in, they're looking at our code, maybe the implementation of the code is very complicated. Well, if they look at the unit tests, even not just at the names of the unit tests, well, we can expand and here's the code. It's documentation. It's self-documenting the code. Okay, so it's very powerful. All right. What I wanted to do now, and let's see, I wanted to, and how are we on time? We have 10 minutes. Okay, so we'll skip this. I really wanted to go in and show you test-driven development in action, like step by step. But at the very least, can we take a moment? Can someone explain to us? So I just showed you what unit testing is, right? So what are unit tests? So now you kind of have an idea of what are unit tests, a very low level kind of tests. But what's test-driven development and how is that related to unit testing? Anyone?
It's where you write a failing test and then write code to make the test pass, and then iterate through so the tests drive what you're developing.
I want to hear some new voices, guys. I see some familiar faces. If you feel free, let's hear some other people. Don't be shy. And there's no wrong answers. So if someone knows a little bit about test-driven development, what is it to you? It can be explained in many different ways. Go ahead.
What you do is that you define the behavior, like how you want the code to respond, and then you write the code that matches this behavior that you're expecting, right?
Yeah. Someone else wants to add or explain it in your own words? Okay, so let me help you out. So at a high level, let me first say this and then listen to what I have to say. Avoid thinking of TDD, test-driven development, as a way to test code. Okay, avoid thinking of test-driven development as a way to test code. Think of it as a way to develop code. Okay, test-driven development is a way to develop code. It just so happened that as you're developing code, you're creating these tests. Okay, and so that's the difference between just saying unit testing. Okay, I write my code and then later someone else will write unit tests for it. That will never happen. TDD is a way to develop code. It's just that it's driven by these tests. And I wouldn't even call it tests. I would call it, what are the different scenarios that mean that the code worked, right? Defining that before you actually implement the code. So, and as someone said, it's a very iterative process. Okay, it's iterative. You kind of repeat these small steps. Usually you first write a test. And when I say write a test, you write code that tests some small aspect, right? Let's take the transfer money between bank accounts. Let's say our first test, happy path. Let's write a scenario that transferring $100 from my account to your account works. I have the money, it should work. Okay, so we write the test. Then we run the test and see it fail. Why do we want to run the test and see it fail? We haven't even implemented the application code yet. We just wrote a test and then we run the test and we want to see it fail. Why do we want to see it fail?
Because if it passes, we might not need to write any code.
Yeah. If we haven't consciously written code yet to make the test pass. So if it passes before, either something is wrong or something is right, but something's going on. Like we need to be aware of that, right? Because we wrote the test, but we haven't implemented the code to pass the test. So usually you want to see it fail, just to kind of like a conscious check in your mind that I did come up with a new scenario that hasn't been implemented yet. Okay, so then third step, we write just enough code to make it pass, right? So now we're actually writing application code to make it pass. How do we know if our code works? We rerun our test. It may fail first a couple of times and then it will pass, right? And then repeat, come up with a new scenario, run the test, see it fail, then write just enough code to make it pass, run it again, see it fail. Ooh, we have 4 minutes. Okay, Gene, is there some wrap-up stuff you wanted to do? And if you did, I just want
Not
to...
necessarily, no, just maybe you want to
Okay.
take my suggestion, maybe you want to just wrap it up natural and maybe you want
Yeah. Okay. I only have 3 more things. I did want to go in and show you how to do test-driven development so you can appreciate it, but we definitely don't have time for that. I have 4 minutes. Let me do this real quick. I want you to get an appreciation for shift left testing. Anybody heard that term before? Shift left? Fancy word. Let's see what we're actually talking about when people say shift left. So let's take a look. Let's take a step back and talk about testing in general, right? Actually, let's talk about the cost of fixing defects, okay? So this guy, Casper Jones, he wrote a famous book about estimating software cost. He found this trend across industries, okay? that was pretty consistent for fixing defects, okay? And he found that fixing defects during functional testing, this is the traditional way of working, costs 10 times more to fix. The cost of fixing defects during system testing, 40 times more. Now, if you wait till it's in production, 640 times more expensive to fix those defects, okay? So the traditional way of testing, we find defects so long after the code has been written that the cost becomes very high. Now, why is it high? Why? Like, why? Come on, why? Well, I'll tell you why. One reason is that by the time we finally get to attempt to fix things, we already forgot our code, how it works in the first place, right? It's been so long since we wrote it, and now you find bugs and we have to go in and fix it. It takes us extra time just to remember what we did. The other thing is, by this point in time, remember, we wrote the code, we put it into version control.
Now, how flyers handle these flight delays. Here's some tips with our travel expert, Saglier.
I hear the news from someone. Thank you. This code, the code is already integrated with other developers' codes. It's much harder to fix things. You know, if we find a bug before we integrated with everybody else's code, it's much easier. So shift-left testing is basically when we find the bugs as we code. How do we do it? Unit testing, or TDD to be more precise. Okay, I don't have time to go really through this. What's in it for you? Like, what's the value? I know sometimes these slides come up and it's kind of like blah, blah, blah. I really wanted to dig into each one and show you how it simplifies debugging, how it simplifies integration, improves agility, improves quality, reduce cost. I wanted to show you. We don't have time to do that. I'll just show you one more thing. I know we have 1 minute. Skills to master unit testing. At least this will be on the video and you can search these up because I don't have time to talk about them. But if you want to get better at unit testing, you want to acquire these skills. Okay, again, I don't have time to get into them. Thank you very much. Gene, back to you. I hope everybody has a lovely weekend.
I want to thank you personally, Asaf. This has been super impressive. I don't think we did enough justice covering. I think you wanted to have more time with details. Maybe we need to replan it, and I think of a way to get even more audience involved. This is great stuff. Everyone, please follow Asaf's YouTube channel and look out for his content, as well as for this information, for this event's recording. Super insightful. And I actually know a few places where I would like to actually shamelessly share the recording internally, because they're looking for experienced technical coaches that can teach this kind of stuff. So I just want to thank you once again, everyone, for joining. Enjoy your upcoming weekend, and stay cool, stay in the shade. I think it's going to be hot in many places. Asaf, thank you once again. Thank you very much. Send me your assets, whatever you got.
Okay.
Supplement a great recording that I'm gonna have hopefully in a couple hours. Thank you all.
Okay.
And, have a great weekend. Cheers. Bye-bye.
Bye, everyone.
Thank you.